In this video, we're going to see how we can generate interval estimation for population mean. For this, we're going to use data file NewBalance. Building upon the sampling distribution for X bar, here is the final formula for the interval estimate of the population mean, mu. So the interval estimate for the population mean would be X bar sample mean plus n minus a margin of error, plus for the upper limit of the interval and minus for the lower limit of the interval. And then this is the margin of error. Margin of error for population mean would be a t-value, t half of alpha, times standard error. S divided by square root of n is called standard error. We talked about this as S divided by square root of n as the estimated standard error for X bar, and we call it a standard error. Standard error, when multiplied by t half of alpha, this whole thing is called margin of error. So X bar plus margin of error gives us the upper limit. X bar minus margin of error gives us the lower limit. T is a symmetrical distribution around 0, is very similar in shape to standard normal distribution, except that it has actually degrees of freedom. So it actually takes a parameter, which would be n minus 1, sample size minus 1. And it's a little flatter than the standard normal distribution. The reason we use T and not Z or standard normal distribution is because we are using S and not sigma for X, for the standard deviation of sample. So this is an estimation for the standard error. I'm not gonna really go into too much detail, but at the end of the day, this is the formula that we're gonna use. Alpha is called level of significance. 1 minus alpha is called confidence level or coefficient of confidence or confidence coefficient. Alpha would be basically the chance that the interval that you're generating does not contain mu at the end of the day. So that would be kind of an error. The chance that your interval does not carry or does not contain mu. So that this is how we define the level of significance. Here we have the definition here. The probability that the interval estimate procedure will generate an interval that does not contain the population mean. And 1 minus alpha, 1 minus level of significance would be the coefficient of confidence or confidence coefficient. All right. So now I'm going to use data file NewBalance, and we're going to see how we can generate interval estimates. So here's the data file. So if we want to use this formula, we need a few items. We need standard deviation, we need sample size, we need t-value, and we also, for t-value, we need sample size again, n minus 1, and we also need alpha, level of significance, and we also need the sample mean. So I'm gonna generate these values. We're gonna first use the formula. We're gonna find all these items one by one and apply the formula. Then I'm gonna use the descriptive statistic tool for basically getting the margin of error, which would be a much faster way. But I'm gonna first start with the hardest way, basically, which would be getting all these items one by one. So I'm gonna start with sample mean. Sample mean would be, so we are first, let me just write down what we are trying to do here. So we're trying to find 95%. So I'm assuming my confidence coefficient is 95%. 95% confidence interval for a interval estimate with 95% confidence, or we can call it 95% confidence interval for population mean. In this case, these are sample numbers from the credit card balance of US citizens. So 95% confidence interval for population mean of, I mean population mean of credit card balances in the US. All right, so this is what we are trying to find. 95% confidence interval for the average balance of credit card balance of US people, US citizens, right? So now we have if I go to the I'm just gonna format this. All right, sample mean. So I mean, we already know average of the credit card balances are sample. That would give us the sample mean. Then we had X bar in the formula. We also need sample size. Sample size is going to be simply count or count A of our sample. So sample size. We also need a level of significance. Let me just write confidence coefficient and then level of significance. So confidence coefficient is given to us to be 95% in the question. So level of significance is going to be 1 minus confidence coefficient. So the sum of these two should be 1. So this is how you get this one. Level of significance, you just look at the confidence coefficient that is given to you, and then you just deduct that from 1, and that would be your level of significance. All right, so we have the level of significance. Looking at the formula here, we have, we got N, we got X bar, we need to find S, and we also need to find the T. So S would be sample standard deviation. That would be stdev.s of my sample. All right, so that's sample standard deviation. I said if we divide sample standard deviation by square root of sample size, that would give us standard error. Sample deviation, sample standard deviation divided by square root of sample size, that would be standard error, sample standard error. All right, so now we now need to find the t value, or t half of alpha, and for that we need to use this function, t dot inverse of as you can see, this one, I mean, you have two options for the t distribution. You can use two tails or one tail. I'm personally more comfortable with one tail, but you can use either one, really. It's just when you're using this one, you will give alpha and it will give you the t half of alpha. So this is the only, but here you would give the half of alpha as your uh, probability value. So probability, if you're using one tail, if you're using t dot inverse, probability is going to be the probability to the left of the point that you're looking for. And that would be, we're looking for t value half of alpha. So this one will be t half of alpha, alpha being the level of significance. And degrees of freedom is going to be n minus 1. Sample size minus 1. So this is how you can get it, and it gives you almost 2. So the reason I use 1 minus half of alpha, because I was looking at the right tail. I'm looking for a positive number. Remember, t distribution is a symmetrical distribution around 0. If I just take this one, I said 1 minus half of alpha. If I just take half of alpha, it's going to be the same number negative at the other side of the distribution, right? Since I'm looking for a positive number, I just put 1 minus half of alpha, which would give me the same number at the other side, which would be positive this time. So now I have almost all the ingredients for finding the margin of error and for the interval estimate at the end. Margin of error, I said we call t value times standard error as the margin of error. So now we have the margin of error, we have the sample mean. So 95% confidence interval for population mean would be simply sample mean plus margin of error, that would be the upper limit, sample mean minus margin of error, that would be the lower limit. So I come back here. So let me just take this and take it, put it here, and now I have point estimate for population mean, that would be simply sample mean. I have upper limit and I have lower limit. Upper limit would be sample or point estimate or sample mean, basically that's the same thing, plus margin of error. Lower limit would be point estimate minus margin of error. Now, this is, so we got the 95% confidence interval for population mean. So what does that mean? What these numbers are telling us? So they're telling us that with 95% confidence, the population mean or the average, I mean, in this case, balance, credit card balance for US citizens, is the average credit card balance for US citizens is between 83.56 and $10,267. With 95%, so we can say with 95% confidence that the average credit card balance for US citizens is between $8,356 and $10,267. And there is also 5% chance that we're wrong, which means that it can be either lower than this number, lower than the lower limit, or upper or higher than the upper limit. So this is if you want to get all these ingredients one by one and just do it this way. So that's the detailed way. There's a relatively faster way. You can get this margin of error. If you can get the margin of error and the sample mean without writing all these formulas, that would be much faster, right? Because the point estimate is the sample mean, and then upper limit and lower limit, we just need, for these two, we just need sample mean and margin of error. We don't need to really go through all these computations in between. So for this, if you use descriptive statistic tool in Excel, so data tab, data analysis, descriptive statistic tool, here, input range, this is going to be, I mean, if you can check labels in the first row and then take the NewBalance, the header here, all the way to the end. The variables are, here we have just one variable and it's in the column. Sometimes you may have multiple columns. When you select all of them, you check this one, and that would make sure that each variable is represented in one column. Sometimes you may have your variables defined in each row. That, I mean, if that is the case, you just check the rows here. But group, this is good for us. Output range. I'm just going to put it right in front of my table here. And so this is where I'm going to show it. But what do I need? I need to check the summary statistic. That would make sure that I will get the sample mean that I need. Also, I need to check the confidence level. Confidence level in Excel terminology is the same as margin of error that we're looking for. So I just check this one, confidence level for the mean, and I just need to put whatever number that I have for the confidence coefficient, which here happens to be 95%, and 95% is usually the default. And I'm gonna most of the time use 95%, but this can be 99%, 90%. So that's really not a big deal. So this is really what we need to get, okay? So now you see, we get the mean and we get the confidence, what Excel calls it, confidence level for the 95%, which is basically the margin of error. You see, it's exactly the same as what we had. So now I just need to get, if I have this one, our job is not done yet. So we need to really get the point estimate. We need to get the upper limit, which is the point estimate plus margin of error. And we also need to get point estimate minus margin of error, which is our lower limit. All right, so this is how we can build the interval estimates for the population mean.